There's this incredibly common belief out there that dividing work up into highly specialized tasks makes a system faster, more precise, and just fundamentally more efficient. We've all heard it, right? But if you actually look closely at the architecture of modern organizations, you're going to spot an immediate, glaring contradiction. If you observe a hyper-specialized system for long enough, you'll find a structure where local optimization mathematically guarantees endless global rework. The people inside the system, they're acting completely rationally. Every decision makes sense on a local level, and yet the final output is continuous chaos. There's this unseen structural force at play, quietly locking the whole system into a perpetual, exhausting cycle of correction.
Just let that contradiction sit heavily in your mind for a second. Optimization creates rework. Now, our instinct is almost always to blame this chaos on something human. We want to say it's poor communication, or bad management, or just simple human error. But what if none of those are the actual cause? What if an invisible structural constraint, something built deeply into the very way we organize human labor, is actually forcing this continuous chaotic correction? To really understand how a system can be perfectly designed to endlessly fix its own newly created mistakes, we need to strip things down and observe the sheer mechanics of separation.
So let's build a really simple physical system in our minds. Imagine a high-pressure steam pipe running right through the middle of a busy factory. And attached directly to the side of this pipe is a single pressure gauge. Standing right in front of that gauge is a single operator, just watching the needle fluctuate as the steam naturally builds up inside.
Now, we're going to add a pressure valve to the pipe. At first, this whole setup operates flawlessly. It's totally seamless. And that's because the exact same person who is reading the gauge is also the one physically turning the valve. As they see the pressure dial tick up, their hand just instinctively adjusts the flow to compensate for it. The observation and the action, they're completely unified. There's literally zero distance between the raw information and the physical execution of the task.
But here's the catch. A unified worker is notoriously difficult to scale up, and honestly, they're difficult to measure too. So we decide to escalate the system. We decide to optimize it by building a physical wall right between the gauge and the valve. Now, on paper, this is a purely rational decision. We are separating the operator who reads the gauge from a newly assigned dedicated operator whose absolute sole responsibility is to turn the valve. We've just created two highly specialized roles, explicitly designed to maximize individual efficiency. But observe how the system has fundamentally transformed here. It is now literally severed information from action. The planners, the ones reading the gauge, are permanently left with pure data, but they possess absolutely zero physical control over the machine. Meanwhile, the executors, the ones gripping the valve, possess total physical control, but they have zero access to the real-time data. That unified craftsman we started with? They've been split right down the middle. One mind plans, a totally separate set of hands executes.
And as that physical and organizational distance between the gauge and the valve widens, a really critical friction starts to emerge in how commands are transmitted. The planner now has to essentially shout through the wall to the executor. The information has to be formatted, then transmitted, received, and finally interpreted, all before it can actually be acted upon. This isn't a communication failure. This is just a law of structural physics. Distance inherently creates delay.
And this delay, it is the absolute silent killer of separated systems. The instruction simply takes time to travel through the void. Think about the timeline. At 0 milliseconds, the pressure gauge is read. At 400 milliseconds, the command to reduce pressure is finally sent. At 800 milliseconds, the valve is actually turned. Do you see what's happening? This means every single physical action taken at the valve is based on an old, outdated pressure reading from the gauge. The executor is entirely reacting to the past, not the present.
And this delay severely escalates the consequences. Because the input, the volatile steam pressure inside the pipe, is changing way faster than the system can even respond to it, a purely mechanistic flaw starts to emerge. By the time the executor turns that valve to lower the pressure, well, the pressure might have already naturally started to drop on its own. So the system inevitably compensates for the delay by overcorrecting, which instantly triggers a violent swing of pressure in the exact opposite direction.
Before we watch how this architecture permanently locks itself in, I want to briefly mention Sift. If you're looking for a calmer way to stay informed, Sift is an app that highlights only the most important news, completely avoiding the endless scroll of headlines and sensational content. You can find a link to it down in the description. It really is just a quieter way to understand the world. Anyway, let's get back to our escalating system.
Our system is now completely trapped, reacting to its own delayed reactions.
Those delayed correcting signals cause the steam pressure to swing wildly, from way too high to way too low and then right back again. It creates this agonizing state where the output is constantly searching for a baseline it can never quite catch. In attempting to perfectly control the system through specialized separation, the system has actually begun to violently hunt for stability.
We can finally reveal the hidden structure that's actually governing all this erratic behavior. This violent oscillation is the biological and mechanical reality of a negative feedback loop. Now, normally negative feedback stabilizes a system, like cruise control in your car. But when a lag or any kind of physical distance is introduced into the arrival of that correcting signal, it inherently causes the system to overcorrect and hunt. Simply put, the separation of the gauge and the valve broke the timing of the feedback loop.
And we could actually trace the root cause of this structural design right back to a philosophy engineered over a century ago: scientific management. Pioneered in the gritty industrial steel mills, this theory demanded the strict separation of planning from execution to maximize efficiency. It was incredibly carefully engineered to completely eliminate the intuition of the unified craftsman, replacing it with isolated, highly standardized, and easily measured optimization. The rule was simple: managers plan, workers do.
Once this dynamic is in place, escaping from this paradigm becomes increasingly impossible. Because as an organization scales up, that wall between the planners and the executors just gets thicker and thicker. The division of labor deepens, locking workers into increasingly rigid, incredibly narrow roles. Over time, both sides become completely alienated from the overall process of production. The planner only ever interacts with abstract metrics, the executor only ever interacts with the physical mechanism, and neither of them ever truly sees the steam. Because this kind of hyper-specialization absolutely demands isolation, the system loses all of its alternatives. It becomes fundamentally rigid. The organization now has to spend far more energy just attempting to coordinate the lag between these separated, isolated departments than it spends executing the actual work itself. It requires endless meetings, massive status reports, and entire layers of middle managers, all just to manually bridge that artificial gap we built between the gauge and the valve. All the system's energy is entirely consumed by the friction of the divide.
So we are left with a very cold, mechanistic reality here. This continuous rework, the violent oscillation, the perpetual misalignment, they are not the result of human error. They aren't the result of poor management or lazy, unmotivated employees. They are the inevitable, mathematical certainty of a disconnected feedback loop. By blindly optimizing the local parts, the system utterly destroys the timing of the whole.
When we look at a massive, complex organization trapped in an endless cycle of creating and then fixing its own errors, we naturally assume that something has broken down. But that assumption relies on the idea that the ultimate goal of the architecture was unified action. It wasn't. The goal was specialized isolation. The chaos, the lag, and the endless, exhausting rework were built into the architecture from the very beginning. The system was never failing. It was following its structure.